Another thing I'm changing this semester to make you more prepared to potentially write software in the real world is to look at how we take code that we develop and make sure it works, make sure it gets built automatically, make sure it gets saved somewhere for others to look at it, make sure it gets deployed and packaged properly, and all that good stuff. So today we're going to focus on the development process. I mentioned last week that because we have so many students in this class, I have to automate things. And I realized when I was trying to figure out how to automate things, besides looking at that tool to do it, I emailed that other professor and I think I signed up. I got to check that one out. There are tools that are free. There are tools that do all of this automation stuff that I need, and it's how we develop modern software. And so it might be helpful or will be helpful for y'all to learn. All right, so week 2. I already asked if y'all got me your homework. I hope you did. So there are 2 parts of this that we're going to look at. The first part, we're going to look at github.com. And GitHub is a version control system for storing software, for storing source code. Then we're going to look at the CI/CD development pipeline, or continuous integration, continuous development. This is a acronym meaning once your code is checked into your repository, it'll be automatically built, tested, validated, and all that stuff. So we're going to go through those steps. So those are really the 2 big things we're going to talk about tonight. All right. First, I know some of you said you had GitHub for other classes, so this might be a refresher. Some of you may have no idea what version control software is. Reading, version control systems are a category of software tools that help a software team manage their source code over time. Version control software keeps track of every modification, special kind of database. If you screw something up, I stopped reading. If you screw something up, you can roll it back to the old piece of code that worked. So these tools allow, most importantly, you to save historical versions of your software. So if you've ever written code and it worked and you wanted to make a little change to make it a little faster and it didn't work, it's really hard to go back unless you have version control software, which helps you do just that. In the past 20 plus years, version control software has also really made a big change that lets us work as teams on the same piece of code. So 2 developers can work on the same piece of code, and these version control systems allow them to be merged cleanly. They help find conflicts that can't be merged, and they walk you through how to fix those conflicts. So these tools have really helped be the foundation of good software development. GitHub.com is a SaaS platform. It's a website you can use to store your projects. You made an account, and when you make an account, you can make multiple repositories. Repositories are where you store your code. GitHub uses a version control technology called Git, G-I-T, as its foundation, hence GitHub. And so we're going to talk about what that looks like tonight. All right, so in version control, I talked about storing code. Not only can you store things based on time, like what was the code last week, you can also do things like tag your code to say, okay, I released version 1.1 of my software. I am tagging all this source code at this point in time. So whenever I have to make a patch to version 1.1 of my software, I can start from here. In order to do that, it also supports branching, which means you can take that piece of code at that point in time and start as if it were the basis of your application. I talked about collaboration, and I'm going to show you all of this when we look at github.com. So we will heavily use, you can use Visual Studio Code for all of your development this semester until we get to some more specialized stuff. But Visual Studio Code has a built-in native Git plugin. You can download and install a GitHub plugin specifically, but I have found that that's harder to work with. The native Git one works better. But we use that as part of Visual Studio Code for when we write our software. We'll go through that too. And so when I'm going to work through this example here. So the process starts for all of our assignments. I am going to start with a skeleton application. This application will have a whole bunch of test cases and a skeleton of what your application is going to look like. That way I can run the tests against the skeleton. They will fail until you make them successful. To do that, though, I have to start a project or repository for each of you. And for you to take that repository into your GitHub account, you do what's called forking. So you take my repository and basically copy it into yours, but it maintains a link back to the original repository. So when you make your changes, you can then give it back to me to merge into my branch or my repository. And that's called a pull request. What we're also going to code from GitHub down to our local desktop, do the work, and then push it all back up. So, all right. So I'm going to make sure I cover all of these things when we go through a demo. So github.com. Live demos never work, but let's hope they do today. If they don't, there goes the entire night. This is github.com. I have 2 accounts. So if you watch carefully, I'm going to do your homework for you tonight. And you just have to watch, rinse, and repeat it later. Cool, cool. So here's, I have my VCU account that I made this weekend. This was my experimentation on how to make tonight's lesson and how I'm going to do a lot of grading this semester. So looking through here, I can search GitHub and look across basically every single open source project in the universe is hosted on GitHub. And so if you wanted to learn how Linux tools were built, you can find them here. If you want to know how the core of Firefox was built, it's on GitHub. You can find everything. So I have an account. Oh, I can't see that. This is going to be something important for when you guys log in. So here I have my account. To interact with GitHub, you do it typically over SSH, which is a secure protocol. Oh, where's the setting? It's not the right thing. Under settings, that's where we're going. You have to set up a SSH key. So you put an SSH key. They give you instructions on how to do this. If you haven't done an SSH key for GitHub yet, you can. That's an important one. But I'm going to go back to my project. So VCU CH Fauerbach test repo 1 is some source code. So what I want to do first, I am going to now fork this to my other repository or my other account. So I'm going to log out. All I do is copy and paste the URL up top real quick. I'm going to log back in. Password managers are wonderful. All right. And so here is my real account. Oh, looks like I already did fork it. Let me delete this real quick. How do I delete this? Here we go. So I have a whole bunch of different repositories. I don't know how to delete it. This might be an issue. Anyway. Branches, go to, ooh. Nope, that's not it. Don't you love live demos when I know I want to delete this thing?
Do you have to delete it from the home account?
No, I want to delete my fork, but oh, that's not my fork. That's the real repository. That's the whole problem. Okay, so I've added myself as a account as a representative on that project. So forget I did all of that. Can I? Okay, so here I can fork it. There's see the button up at the top says fork, upper right hand corner. Yeah. Okay. I'm going to fork it. So where should we fork test repo 1? I'm going to fork it into my Chris Fauerbach account. This is not my VCU one. This is my real one. So I click there, and it's going to say this is going to take a couple of minutes. We're going to fork it. And now in the upper left-hand corner, though, you can see it's my Chris Fauerbach account, test repo 1, forked from VCU CH Fauerbach test repo 1. It's the source code at the point in time that I forked it. So now we get to the Git part of things. So if I want to work on this code, if I want to make some changes, add test cases, add a new feature, whatever, I need to get it down to my computer. So I'm going, the verb for that is called cloning. You clone a repository. You can clone HTTPS and clone it over SSH. I always clone it over SSH because I know my credentials are used. So I'm going to now open up Visual Studio Code and close all this. Okay. Oh, but now my recording is not recording this, but that's okay. I'll share the Zoom part of that. So for my code, I'm going to click on, where is it? Oh, sorry. There's a button over here. It looks like the, let me close this project. Code, new window. There we go. All right, now I'm in a fresh window that's not associated with any code. All right, so here, I'm going to click on my version control, which was this little graph looking thing over here, source control. And I'm going to clone a repository. And up in the top, I'm going to put in that URL. So it's Git at GitHub because my SSH keys are all set up. You can also do the HTTP version of this as well. And I pressed enter. And I'm going to save it on my desktop temporarily. Select repository location. And you can see over here it's cloning. Would you like to open the cloned repository? Yes, I would like to do that. So here is my cloned repository. On the left, under my file browser, upper left-hand corner, oops, come back here, I see all my files. So readme.md, it's a markdown file. Markdown is a markup language for simple document kind of things. So here it's a title, and I'm going to make some change. I made a change. I'm going to go and change some test cases. Whoops. You don't have to know what this does yet, but I'm just adding another. It's called a unit test for my application. I'm adding a doc string, which we're going to talk about at the end. What the heck? I don't want the Python getting started. assert that 1 is my module. Function add 3. What is happening? I must be making some keyboard stroke on this keyboard. Equals what? 6. So adding 1, 2, and 3 together should be 6. So I'm saving that. All right. So under here, making sure all my files are saved. And here I have 2 changed files. Well, I'll go back to my clone or my GitHub or source code change. Where do we go? Oh, I think I need to stash these. So I do all this from the command line, so I'm really not good in a IDE, but we'll figure this out together. Made my changes. How do I make my changes? Unsaved. I totally hit save. Oh, maybe I didn't. Save. Save. Now you can see there's a 1 on the 2 on the GitHub Git link, source code link. So here are the 2 files that I've changed. So I want to stage those changes. I click the plus and I click the plus, and I have to put in a comment. I made some changes in class. Now I'm going to commit those changes, and then I have to push them back to GitHub. So I'm cloning, changing, adding, committing, then pushing. Clone, commit, no, clone, add, or stage is a verb they use there. Commit, then push. So I'm pushing those changes. It's doing a little spinny thing. Why not?
And so just to translate this to layman's terms, you had saved your changes on your local drive, and so the commit is sending them back to your own repo, but not to the original repo. Does that sound right?
Not quite. The commit, the add and the commit are local still. The push is when it goes back to GitHub.
Okay, so just to clarify, the push is going to your own repo, but not the original that you forked.
Good point. Yes, exactly right. I'm going to my command line because I can walk through that better. Oops. If I look at a command line like this, does this mess you up? Unless I can explain.
If you walk us through it, then we can
go through it. So I can show you the command line information. So I cloned it. Let me check my status. So I'm good. So the last thing I was going to do is the push, but I'll do this all over again with another change. So push, you can see here, it says it pushed it to Chris Fauerbach test repo 1.git. So when I go back to GitHub and I refresh, we will see my changes. But if I go back to the source one under VCU, the changes are not there yet. So to get those changes there, I do what's called a pull request. I'm saying, hey, original maintainer, I have some code for you to pull to you. So I'm doing a merge from Chris Fauerbach, this is right to left for some reason, from head repository, Chris Fauerbach test repo 1 to VCU test repo 1. The branches automatically get merged. There's only one commit in there. Whoops, I shouldn't have clicked on that. And I'm going to create that pull request. Please accept my pull request. And I click create pull request. And now GitHub does some stuff to say, yep, double check. So since I am a maintainer on both sides, on the origin, which is the VCU, as well as the fork, which is my Chris Fauerbach, I can actually I can merge the pull request. So that's me as the original maintainer VCU accepting that change back into my repository. Draw that up. That would probably make life easier. I'll do that. Pull requests. So it should be closed now or merged. Yep. So we're closed. And now if I go to the VCU origin, I now have the changes. Atlassian's going to have really good pictures. Here we go. So your repository, you create it. Your main or master branch is the working branch. Show me a picture of, well, I don't want to show a branch. I haven't found a good picture yet. All right, I'll find a good picture for you later. Okay, so I'll make sure I covered all my things. I cloned it from github.com to my local computer. When I make a change, I add the, so if, think about the whole thing as a transaction. Anybody not familiar with like a database transaction? You can do multiple things before you commit it, like the finalization of the whole transaction. So every time I make a change to a file, I'm basically adding it to the commit before I commit it. I'm adding it to that transaction. I can change 34 different files. Then I add each file to the transaction. When I'm done a transaction, I hit commit or I type commit. From there, I can then push it back to the repository. So clone gets it local. Add and commit are local operations. Get updates your local with what's on GitHub, and pushes it back to GitHub. We did a pull request. We don't have to talk about branching yet. Does that make sense? Has anyone not worked in version control before? I saw a head shake, a hand raise. Okay. All right. So we will take our time when we go back to doing that again. All right. So that was the kind of foundational to get us to what we can start to consider a CI/CD pipeline. CI/CD again stands for continuous integration, continuous deployment. What it means is there is some sort of workflow that happens when you commit your code, when you push your code back to the repository. In GitHub, they have something called GitHub Actions. Those actions can be triggered on that push back to the repository. There's software called Jenkins, which a lot of people use for running things like this. Typically, you'll start with running your unit tests for your code first. So what we're going to do here is show how I can test my code and build my code automatically using GitHub Actions today. So the fundamental component of a CI/CD pipeline is having your code be tested. The way we do that is we write unit tests, or we write integration tests, or we write tests that can be run automatically so that we are comfortable with our code. The dream of every software engineering organization is I make a change in my code, I press save, I push it back to GitHub or my version control system, and it ends up in production without me having to touch anything. That dream is not often seen, but that's the way you need to think about building test cases for your application. You need to be darn sure that it's going to work when it goes in front of a customer, because you don't want to go back and have to manually roll something back. You don't want to have to find a bug in production, all this kind of stuff. You want to make sure, and you don't want to actually your question. We don't do that anymore. That's something we used to do. And now we have tools and techniques to do that for us. So you need to make sure your code is safe or is functional. So we'll harp on test cases a lot, and that's going to be how a lot of our homework is tested and graded. So I'll show you what that looks like. Oops. All right. So I mentioned Jenkins. Travis CI is another. Travis Continuous Integration. GitHub Actions, which is what we're going to use. So the pipeline that we are going to be using to start off with is going to run a bunch of tools that you don't know what they do. They're going to validate coding standards, style guidelines. They're going to make sure your variable names aren't spelled wrong. They're going to make sure you're properly indenting everything. PEP 8 is the Python. This is crazy. If you ever want to like try to understand what people think when they talk about writing Python code, some people go nuts. Anybody watch what's the HBO show Silicon Valley? Early episode, tabs versus spaces.
With Richard and his girlfriend.
He has to leave.
Yeah, that's a Python joke. If you didn't pick that up, but Python, everything is organized by white space. So in C#, in Java, in C, your blocks of code are surrounded by squiggly parenthesis like things. In Python, it's all white space. So tabs or spaces. The right answer is space, if you are curious. But anyway, this is like dozens of pages of how to write Python code properly. Like, this is too long of a line of code, so don't write that. Write it like this. Like they're very specific about things. So we have a tool that validates our code against that standard. There's a tool called iSort, which looks at the imports of your packages and makes sure they're organized properly. Pylint, it checks to make sure your code is functional, make sure all the style guidelines are right, and then Black does the similar thing, but different and better. And we'll package your code, and then we will run our unit test framework called PyTest against your code. So all of these things will happen when you submit your code to GitHub, which is kind of cool. If it passes, you know you got it right. So if we look here, my Python packaging, which is where my unit tests run, passed. Pylint and Superlinter does a whole bunch of this stuff in one kind of tool, but it all passed. That's great. But in a moment of self, I don't know what the word is. It took me an awfully long time to get this right. I want to show you how long in hours this took me. And I know what I'm doing. But I do it once, so y'all don't have to do all that. Because I've never used GitHub Actions before. It's just kind of a newfound and new cool thing. But I started, let's see, do they give me a timestamp? At 1:30 on Saturday. And the first time I got all three to pass was linter, package, and Pylint. Here we go. I think that was it. I think this is the first time I got it all to pass at, come on now, 11:12 a.m. Eastern. So I think these are UTC timestamps. So I think I started at 8 in the morning and it finished at 6 p.m. It took me all day. And the code I wrote is really stupid. It's not real code. Anyway. But all these tools run. So looking at let's look at the different ones. So Pylint is the first thing. Linting is making sure your code is organized right. So I can look at the lint and I can say, show me the details of it. It does a lot of stuff to set it up. It checks out your code, sets up a Python environment, installs dependencies. Here's the actual analysis. So it runs this command, which is finding all your Python code and sending it to Pylint, and it worked. Let me show you what it looks like when it doesn't work, because that's where you learn stuff. So I had an unused import that says that's an error. Your code should not have unused imports, so it failed it. Over time, I'm going to figure out like the best validations. This thing is super, super picky. I'm going to find out what's a good thing to block on and what's not a good thing to block on. Let's go to the packaging though, the actual unit tests. Did it only run once? So here this one couldn't find my test cases, which was weird. Where's the one that did work? Linter. Here we go. So here I see some errors. It couldn't find my code and stuff like that. But anyway, so those actions are defined in my code. So if I look back at the repo, GitHub has a magic hidden folder called .github with a workflow folder, and I can set these things up. So my PyTest, this is one of the stages in my build pipeline that it's called Python package. When I push to my repository, it runs it in Docker. If you're familiar with Docker, it runs a virtual or a container environment on Ubuntu, which is a Linux operating system. Checks out the code, sets up my version of Python, make sure it's the right version of Python because I have a list of the ones I will compile against, installs dependencies like PyTest and others I need for whatever this code is. And then it runs PyTest. So PyTest, actually I have a slide for that. I don't want to get too far ahead of myself. So those are all the steps that it takes to get through this validation. You will learn about how those steps work. But I don't expect you to become like a iSort master or a Pylint or a black master. All right. Now we're going to start looking at actual, like, how do we Python? Anybody ready for like, how do we actually Python? Yeah. Okay. I got one enthusiastic head nod. All right. Everybody else is enthusiastic too, I'm sure. All right. So, excuse me. Here's a organization of a Python application. So if we think about a GitHub repository, the things on the left, setup.py, my package, and tests, are top level. So those are the top level file. Setup.py is a file. My package is this is a placeholder name. This is named for whatever your application or module is that you're building. And then we always have a tests folder where we have our unit tests. Under your package folder, you have whatever Python files you need for your application to work. ini.py __init__.py is an empty file usually, sometimes. It just tells Python that this is a Python package folder. We'll get more into that. But app.py, view.py, these are things I would build if I were building a web application. Then I have a test file per source code in my application, per file of source code in my application. That way I can kind of organize my tests as well. So setup.py, it has some metadata about your program. Tells you what it tells what the package name is, what the package folder is, and other information in there. We'll look at that in a second. Any.py is, oh, there's supposed to be underscores here, but I guess they're not showing in my markdown. But this is right. And then the test is where our unit tests are. Any questions about that? Or are you going to hang back until we actually get to some code so it makes sense? All right, cool.
Are all of those folders required, or is this best practice?
These are best practices. So my package in this example is the name of the package. In my GitHub repository, it was test repo 1. That maps to in that setup.py file. The name of the package is test repo 1. So that matches that folder name. So this top level, like this license file, this is a GitHub thing. README, GitHub thing. Requirements.txt is a list of the dependencies I need for my application. That's a Python thing. PyTest.ini is a configuration thing for PyTest. Pip file and pip file lock, those are again dependency management things, but we'll talk at length about those. Oh, why is it somehow it failed? I didn't even do anything. Oh, it failed because I probably didn't actually let's find out why it failed. I don't think I did the white spacing properly on that new unit test I made. These things are crazy picky. I'll configure it so it's less picky for y'all. Or maybe I won't make you get picky. So since it failed, it gives me all the output, which is actually really nice. I don't know why there's an opossum. I guess that's an opossum. So it's running through all this stuff. GitHub, linting a whole bunch of files. Here we go. Found errors in the black linter. Black is the tool. And it says it would have reformatted this file. And I'm guessing I have extra white space in there or not enough white space or something like that. I'll tell you, I will tell you by the end of tonight how to fix that before you check in the code. And now I can actually do that for real.
And so how would we check if that's too much white space or too little white space?
I will show you that. I'll show you that before we're done.
Excellent.
Yep. All right. So unit tests. The idea here is to test small pieces of your code. So when we write code, we organize it by classes, modules, functions. We try to break up and organize the code into small pieces of functionality. And the reason we do that is so we can test those small pieces of functionality. If you had a function with 334 lines of code, 17 if statements with permutations of logic paths, like too many of them, it's really, really hard to test that. So you want to simplify it and break it down to much smaller organized pieces of logic. One big reason is to make it easier to test. The other is easier to read and easier to change and all that kind of stuff. So we don't want large blocks of code. If we have large blocks of code, we need to start breaking it up. We always test our inputs and our outputs. So the two functions I wrote in that test thing were, the first one was adding 2 numbers together. The second one was adding 3 numbers together. So I know the inputs are supposed to be 2 numbers or 3 numbers. And I know the output should be a number, right, that equals those adding to each other. Like, look, so that's when I look at my code for that, my test for that, I'm asserting, assert is a test language, a test word, meaning if the value here, in this case, it's the return value for my function, equals 7, then good. Otherwise, that test was not valid. So I'm asserting that these two equal the same. If they don't equal the same, then the test will not pass. And I do this unit test like this, so over time, I can make sure that that function always works. If I make a change to that function and it breaks, my unit test will tell me, and I'll have to fix it. So that's why we unit test. And a good practice in unit tests is to test edge cases and boundaries and all that kind of stuff. So if you're expecting to add two numbers together, what happens if you pass in other data types? Oh, our code should know what to do if they're not two numbers. And our test cases need to make sure the function does what it's supposed to do when it's not two numbers in this example. So that's kind of edge cases and boundaries. If you're adding two numbers, what happens if you pass in a negative number, a positive number, 0, infinity? Those are kind of your boundary cases as well. So we always want to kind of test a wide range of things. So mine was not complete because it was one single test per function. Now, that function had one line of code in it because it was a naive, super basic function. But if this were something I was really building for a real application, I'd want to test it a lot more. So that's what unit tests are. So an example, we're going to be looking at a little code, and I understand you don't know Python yet, so I'm going to walk through it. So don't get hung up on the language, please. So I start every every Python file with what's called a doc string. We can put strings when we make a string in Python. You can either surround it by a double quote, a single quote, or a triple double quote. You do a triple double quote. See what I mean? 3 of them double quote with me. So use a triple double quote typically for multi-line files or multi-line strings. So if your string has a carriage return or a new line in it, you typically do a triple double quote around it. But in this case, for doc strings, we use it as well. So this doc string, it just tells me what my module is going to do. This is a file to hold class definitions of test code. Import is me telling the Python interpreter that I need libraries. I need functionality that's not in the base of function, or base of Python. So in this case, I'm going to use the unit test library. I'm creating a class called test list elements. It extends the unit test.test case class. Then I have another doc string for my class itself.
Is that basically just a comment?
It's just a comment. Yep. Now, if your function is like a real function and has multiple inputs and is complicated and you need to describe it, you would do more a doc string that's not just a single line that says this is what it does, right? You would say, here's the input parameter 1 means this, input parameter 2 means this, the return value will be, so they can be more complex, but it's basically a comment, yeah. And then each of our test cases, the function always starts with the word test underscore, and then some unique thing to know what's happening. So here I'm writing a test to make sure the sorting function works with a simple list. So my known input for the function, I'm hard coding 5, 4, 1, 2, 3 in a list or an array. And when it's done, that should be sorted as 1, 2, 3, 4, 5. Pretty straightforward. So I'm, like we just did, assert this function equals 7. There's another assert magic word called assert list equals, which validates 2 lists to make sure they're the same. So here, I'm not actually calling a sort function. If I actually ran this test case, it would fail because these two lists are not the same. They're not in the same order. Did everybody see that? The second one is 1, 2, 3, 4, 5. The first one is 5, 4, 1, 2, 3. So that would fail. But that's a test case.
Sorry, your second variable is called expected output, and so the test is known output. So
that's Chris's attention to detail. That yes.
Okay.
So
cool.
this actually would would pass because it's the same. But yeah, that was supposed to be expected output. And if it were expected output, it would have failed.
Sorry.
Thank you for no. So
No, well, I'm still not clear because we haven't defined what known output is.
you're right. It was supposed to be expected. That's actually what it is. This is what happens. My attention to detail is really poor. And this is why I test case all the heck out of my code. But anyway, yeah, that's supposed to say expected output. I will fix that.
No worries. Cool.
But thank you for pointing that out. And feel free to do that. Because I do this a lot and I apologize for that. That is my worst attribute as a professor.
Quick question, Professor.
Yes, sir.
When you assert or assert equal, does that return an error level or a code of some sort?
Yeah. In Python, it'll raise an exception. So it's an error condition. Sorry, I'm still writing down variable. Okay, cool. So I'll fix that. Yeah. So yeah, here I'm asserting that those two list values are the same. So if they are the same, it will pass on and code will continue. Otherwise, it will throw an error. All right. I think I talked about this one. Pylint website does check coding standards. Make sure your code lines aren't too long. Make sure your variable names are named properly, which we'll talk about, and other things. It does look for bad code as well. So if your code is not is invalid code, it'll tell you and it won't pass. It's called a static analysis, a static code analysis. It doesn't actually execute your code when it does the validation. It looks at your code to make sure the code looks valid or is valid. It scores your code with a maximum score of 10. So as you're writing code over time, you can write code. So you can run all these tools locally on your computer when you write your code. So you'll run Pylint against your code and you'll get a score. If you run as the default configuration for GitHub Actions, if your code does not come out with a 10, it fails. That's not realistic in real life. Like scores of 8 are good enough usually. So I've got to play with my validation to make sure it's reasonable. But just so you know, 10 is the best. It can be negative if it's really bad code, but 10 is the best. 0 is not great, and anywhere in between is like a scale of goodness. So I think that'll be part of my grading. So when this will help you write cleaner and easier to read code. So if your functions are too long, if your functions have 70 lines of code, Pylint will say, your function has too many lines of code, you should break it up. So that's the kind of thing you would say, oh, okay, I should probably break up that function into smaller functions. So that's just teaching you to write better code.
So if we submit an assignment onto GitHub and it fails the Pylint test, does that mean we just get a 0 assignment? Like how does the grading work if it says error or fails?
Yeah, that's what I've got. That's what I've got to figure out, because right now all of my things I found, if it wasn't a 10, it failed it.
It's like a 0, 100. Okay.
Yeah, which again is not reasonable. So I need to figure out what it's looking at to figure out what's really important, right? Or see if I can set a threshold, like pass as long as it's above an 8 or something like that. So I'll get more details on that as I figure it out. Not as I figure out how the tool works, but as I figure out how to make it a grading component. But if you get a 10, then it's the best. So don't worry about it. Just get 10s. That was a joke. iSort, like I said, is another one. When we have libraries or packages that we need to reference, we have to import them. So here I'm importing 3 libraries. One is called requests. This is for making like HTTP requests. The system or sys and OS to do operating system level stuff. Those are kind of like the foundational things that you use a lot if you do user input or status code of your application, things like that. And requests is actually is not part of the Python core library. It's a third-party tool, open source software. It's a nice open source license, so we can use it without having to pay somebody and stuff. But anyway, so this is how I typed it in as my import list. I ran isort against it, and it cleaned it up. According to PEP 8, the formatting guidelines, you're supposed to have first ports alphabetical. No, sorry. First, alphabetical is right. 2 sections. So first section is the Python standard library stuff, like sys and OS, separated by the external libraries that you're including. And if I had multiple of each of these sections would be alphabetically ordered. So that's an easy one. And the cool thing about isort and black, they'll change your code for you. So your code should always work with those when you submit it, because you're supposed to check it locally first, which I'll show you how to do. So like I said, black is it's called a Python code formatter. So it does a lot of the things that a linter does. It makes sure it's stylistically good code, valid code, but it can also format it for you. So this is how I ran it. So I run Python 3 m minus m means the module, means I want to run the black against this code that I'm looking at. In this case, it didn't change any of my files, but sometimes it does. If I put in extra spaces in one function that are different white spaces in the other function, it'll normalize it all, which is really nice. And the good thing is it will do it for you on your computer before you commit it and check it into GitHub. So again, this should always pass, because you should do this before you even check your code in. But it'll still be checked later. So when you run it locally, it will change your code. When I run it in my pipeline, it just says, would it have changed your code? And if it would have changed your code, it'll fail it. Does that make sense? All right. PyTest here, another framework that we'll be using for unit tests. There are a ton of different Python unit testing frameworks. This is like the standard of it. It's actually it's pretty much the standard testing framework. It's simplest in my mind for everything we use. It'll be perfect. Example here, I have a function called inc to increment. So x is a parameter into the function. It's going to return x plus 1. So if I pass in the number 3, the function will return 4. So I'm asserting that inc3 equals 5. This will fail because inc3 should return the value of 4. So in this case, the code's right, the inc function is right, but the test itself is wrong. Anyway, that's as simple as it gets with a unit test. But PyTest is the testing framework we'll be using. Here's what it looks. I had to break it up on 2 slides. When I run PyTest, it goes through all this stuff. It says, okay, I'm going to run my test cases. It ran all my test cases. It ran 100% of them. And here's a list of failures. So my line of code said assert inc3 equals 5. It says, okay, inc3 evaluated to 4, but you were looking at it for 5. And so I got an assertion error. That test case failed. So to get that to work, I needed to fix my test case to make it 4. But then from now on, once I get the test case right, I'll know that that function is always valid. And this, I will make sure it doesn't fail it unless they all fail or something like that. This I think will be an easy mapping towards a percentage of your homework submissions. Like if you get 4 out of 5 test cases, that feels like 80%, right? All right. We're going to learn a lot about environment managers for Python. We mentioned Anaconda last week. I've already mentioned pip files tonight. When I am on a command line, you'll see me use pip env. Pip is a Python environment manager, Python, whatever it stands for. It's an environment manager just like Anaconda. But I can do this same functionality in both. So let me walk through what that looks like. So can you see my command line now? Oops. There we go. Whoops, what the heck just happened? All right, let's say I want to make a new Python application. I'm making a directory on my computer called test for class. I thought I did. Oh. Test for class. There we go. Windows versus Mac. Who using the thumbs up or hands up or whatever? Give me a thumbs up if you're using a Mac. Thumbs up. 1, 2, 3, 4, 5, 6. Okay, is that it? Okay, all right, clear your thumbs up real quick. Thumbs up if you're using Windows. Oh, Lord. Okay. Okay, cool. You can clear this. Now I have a general idea that 80% of you, if not more, are using Windows. So I'm on a Mac. I don't know how to use Windows very well. So I'm not going to be a great help when it comes to Windows issues, if you have Windows issues. But I will do my best, which will involve a lot of Googling. But that's okay. We'll make it work. So I spend an awful lot of time in my professional life in a terminal like this. That's always the first thing I do is figure out how to get to a terminal. If I'm on a Windows machine, how do I do that? On a Mac, it's easy. So anyway, I want to show the difference between what I do on a command line as well as what we'll do in Anaconda, because they'll both work. So here and in both environment managers, I need to tell the Python interpreter that I'm starting a new project effectively. Because when I deal with dependencies like that requests library, I don't want it to conflict with other applications that maybe are stuck on an older version of the requests library. So I need to make my own like standalone, they call it a virtual environment for Python. So I do that by saying pipenv, P-I-P-E-N-V. I want a new Python 3.8 environment. So what it does is it says, okay, I'll set up like the Python native has the virtual environment concept. Pip-env is a third-party application that makes it easier to manage, just like Anaconda is. So here I'm creating a 3.8 virtual environment. It's created, and it created a pip file. And now I'm going to activate it by the pip-env shell command. I do that so I can now, when I type Python, it's the Python 3.8.6, like my virtual environment was made. So I don't have to deal with where is Python on my path and all that kind of stuff. So once I have that, I need to cheat sheet and look back at my slides. So I made the new virtual environment. I opened the shell. Now I'm going to start installing libraries that I need. I want to install PyTest, Black, and iSort. So let's go back to that. So pip, oops, let's do Python, pip and, are you hiding behind your pictures? Yeah, yeah. All right, pip env install Pylint. And it's going to do some analysis and say, okay, what is Pylint dependent on? It's a full dependency management application. And it'll find all the libraries that Pylint's dependent on and install them all.
A quick comment, Professor.
Mm-hmm.
If you're having trouble on Windows versus Mac, Windows users can install Terminal.
Yes. It's going to install the Linux for Windows or whatever it's called.
I think you can just grab a Terminal. It's actually on GitHub. I can paste the link in the chat.
Okay.
I mean, you could do a whole Windows subsystem for Linux, but or you can do a Terminal.
Microsoft Terminal. Yeah, what is this? Oh, is it terminal like my Mac terminal?
Yes.
Awesome. Super cool. It's good for y'all to know. All right. So here it went through a whole bunch of stuff and success, it installed Pylint. Whoopsie.
And so are we spinning up a virtual instance somewhere, or is this on our local machine?
No, yeah, that's what the wording is a little tricky. It is a Python calls it a virtual environment. So it's not like a virtual machine or a Docker container or anything like that. It's just a isolated place where you can dependencies for Python. But you do this on your
Like, is
computer.
that local or is that on some server somewhere else?
It is on your local computer.
Excellent.
Yep.
Should we be doing this right now along with you in our own terminal?
Probably not. And I'll tell you, because you have to install pip env and all that stuff.
Okay.
But I'm just going through what it looks like here, and then I'll show you an Anaconda for if you want to use Anaconda, because Anaconda is really, really nice and easy and convenient too.
And that's different from terminal if we have a Mac?
If you do you have Homebrew installed on your Mac?
No.
Okay. Got to install Homebrew first.
Okay.
I think it makes life easier. That's for everybody on the Mac. Just install Homebrew. I had some weird dependency issues with Black the other day. So I found that this specific version, 20.8b1, didn't have those dependency issues with, I think it was with iSort conflict. I don't know why it's taking so long either. Probably because I'm beating up my CPU recording class. Which you won't see any of this in my recording. So I'm going to have to mix it with the Zoom recording, which will be cool. All right, so I installed that. iSort and Pylint. I can do them both in the same line if I want to. iSort and Pylint. Live demos.
So you're still in this Python instance, but you're installing software almost like it's, like a Linux-based thing. So is that a feature of Python in and of itself, or pip env?
That's that. So it's a feature of pip. So pip is the Python package manager. I think it's actually maintained by the Python people, but it is not part of Python itself. Pip env is a application to make pip easier. So there, so those are all installed. So from here, I can now run black, right? I can do Python black, update my source code. I don't have any source code here. So it'll say no file present to be formatted. So let's make a quick file. This is going to be my demo application. Quick Python file. No, I'll leave that out for fun. Next week, we'll actually look at like Python, unless we get to it tonight if we finish early enough. This function is called add two numbers. It takes two parameters, giving them a label A and B, or a variable name A and B, and it's going to return A plus B. Python does a weird main method declaration. So in every other language, you have a main function that is where your code kicks off. Python does it weird, and I did this wrong. They look for an environment variable called name, and they look and see if it's main. It's odd. I'm going to print out the return value from add two numbers, 1, 2. So this should print out the number 3 if I run it right. Cool. But I didn't write that well. So I'm going to run Pylint against my code. Oops, I need that blank ini file for Pylint to work. Actually, I'll just tell it demo. Just do that demo file. All right, so here I got a score of 0. Boo-hoo. I don't have a module docstring. A doesn't conform to snake case naming style. It's too short. A and B, single letter variable names are bad. B doesn't conform to snake case, missing function or method docstring. All right, so let's fix some of that. So I'll fix my variable names. First number, second number. So I'm not changing my doc strings yet because I want to see if it got a little better. My score, I want to see my score go up. So I got a 5 out of 10 that time. So when I run it, it says your code has been rated 5 out of 10. I did better by 5 points than last time. Yay, me. So this is my module level docstring, my function level docstring, and I think, oh no, I don't need one there if I remember correctly, but we'll find out. So I'll run Pylint again, and I got a 10 out of 10. I didn't get any warnings or any things to do better that time, so I did that well. But you see, I just run Pylint against my code locally. So this way I know when I send it to GitHub, it'll be good there too. I'll do the same for isort. I didn't import anything, so it really won't do anything. Okay, but I ran it. Isort and black both will change your code to make it better. And then we'll see if black does. Actually, I want to make a copy real quick just to see if black does do any changes. Demo to demo backup. Okay, I'm just keeping a backup of it. And I'll run Python black against demo.py. And it said it reformatted my code. All done. One file reformatted. So locally, it reformatted my code for me. Had I sent this to GitHub, it would have failed. But just to see the difference between the two files, because I'm curious, it looks like it cleaned up some white space. Oh yeah. So easiest one to see is I didn't have a separator 1, 2, it put in a separator here to meet coding standards or to meet style guidelines, which Pylint didn't pick up on. Interesting. That's why we're using multiple tools. But anyway, so now all of those things passed against demo.py. So now if I committed this to GitHub, uploaded it, I'd be pretty confident that it worked. Okay, but the entire reason I showed all this was the pipenv stuff. So starting here, I created a new virtual environment. I went to the shell to load that virtual environment or activate that virtual environment. And then I installed my dependencies. So if I were an Anaconda, so Anaconda Navigator is a user interface on top of Anaconda. We can do something very, very similar. So when I start it up, this is what it looks like. On the left, I have an environments tab. These are my Python virtual environments. This is a full list of all my Python virtual environments that I started in Anaconda. So down the bottom, I have a create button. I'm going to create a new virtual environment called demo2, maybe. I'm doing an awful lot on this computer right now. Demo2, I want it to be Python, but I want Python version 3.8. So this is the same thing as pip env space -- Python space 3.8. And I hit create. It's just a nice GUI way of doing it. So down here, you see all this GUI stuff saying, yeah, I'm doing something.
And are these semi-permanent, as in if we exit out of Anaconda and come back in tomorrow, demo 2 would still exist?
Yes, it will, unless you delete it. So like this Spotify test one, I think I made that the first time I taught this class, like 3 years ago. Yeah, these stick around, and they're fairly lightweight. On your file system, they just contain all of the dependencies you installed. Anaconda is always slow on my computer. I probably need a new laptop. I should buy myself one. With all those big bucks VCU pays me. That was a joke.
Have you ever figured out your hourly rate? I mean, just based on
You want me to cry?
I was not trying to hurt you.
No, it's all good. I don't do this for the money. I don't turn down the money, but I don't do this for. I think I did once. Let me think about it. Just class time alone. 3 hour. It's a 3-hour class, so let's say it's 3 hours a week, 15 weeks, 45 hours. Yeah, it's not that much. Plus the prep time, the grading time, all that stuff. So I think people teach because they like to teach, not because they want to make money.
Quick
But
question.
that's okay.
How did you compare the two files in Bash earlier?
There's a program called diff, DIFF.
Got it.
This is still creating my virtual environment. I don't know why Anaconda is so slow compared to pip or pipenv. I'd be curious if it were this slow on y'all's laptops, if they were newer. This laptop's probably only 5 years old.
Yeah, mine was done in just a few seconds, but I'm on a big desktop, so that might be it.
Yeah, so just like a Linux package manager, it has a big database of dependencies, and I know on mine I have extra repositories in my environment, so maybe it's just more. I think it's done now. Okay, cool. So so now I have created my demo 2 environment, and I've selected it. I clicked on it over here. So when I first look here, it shows me, this is what it usually looks like. In my other environment, I installed Pylint. I installed Black. I installed PyTests and iSort. So the basis here, it installed a whole bunch of stuff: OpenSSL, ncurses, pip, Python. Installed a whole bunch of stuff that I'm not sure why it installs. That might be one reason it's slow. Oh, it's doing something. There we go. So now it got all the packages. So to install these packages, right now it's showing me what I have installed. If you can see where I'm kind of hovering, it says installed. I change this to not installed, and then I can type, I want Black. So I checked it. So I just checked the box right next to Black. I know I also want iSort. So I clicked iSort. And what else did I want? I want PyTest. Oh, let's see. Now there's a whole bunch of PyTest stuff, but I just want the base PyTest. iSort, PyTest, Black, and I need a lint, Pylint. And I need to Pylint. Click Pylint. Okay. So once I do that, I can hit apply down here. It's doing all the package management stuff, looking at the dependencies.
So should we assume you don't have those packages in your other environments?
It will download them fresh each time. I don't know if it stores a cache or not, but I think it downloads new each time. Because remember, each environment is version bound. So version 1.1 of Pylint. And if I do this one a month later, it might be version 1.2 or something like that. This is another reason I tend to go to the command line, because my Anaconda is really, really slow. All right, so it's saying
I had
cool.
to update index for it to show.
Okay.
Pylint and others.
Yeah, see, I have Conda Forge in there. I think that's actually the base one. But then I hit apply again, and now it's installing them all. So it's actually telling you where on my computer: users/cf/anaconda3 envs for environments demo 2. It's installing it in that package. So let's see if I can grab. Oh, go away. I hate all these hovering window things. So what that looks like: cd users cf anaconda3 env/demo2. So it's a whole bunch of stuff. I forget where it installs them, but these are all the files that are needed in that virtual environment. I think they install under lib, actually. Yep. So it's going to install them all under this lib folder in there. So it's specific to that demo 2 environment. Like here are all the other, or a bunch of other environments that I have in my virtual environments from Anaconda. So that's how it kind of segments the different virtual environments dependencies. It installs them into a specific location. and they're installed. So to go work in that virtual environment, I go back to the home of the Anaconda Navigator and my applications for demo 2, which is that virtual environment. And what's neat about this now is it has all these applications that you can run for that virtual environment. So for me, we want to run Visual Studio Code. So I know I want my demo 2 environment. I'm going to launch Visual Studio Code. And when I launch for Visual Studio Code for that virtual environment, nope, it will say I'm on a test, say I'm on a Python file.
And is that assuming we have the Git plugin already installed into Visual VS Code?
We have, this doesn't do anything with Git yet. Git and Anaconda and Python virtual environments, they're completely different things. Virtual environments are how you run it locally. Git is how you share your code back to the repository. They're independent of each other.
Okay, and so are there any other plugins we need to have in either VS Code or Anaconda for these two to work nicely?
I don't think so. I don't think there are. Later. So where I need to get to my runner. So there, oh yes, so there's a runner thing. So what's really nice about this is there is a, oh, here we go. So this down here. Can you see down at the bottom where it says Python 3.8.6 64-bit? So I already had Python or Visual Studio Code running. If I had not, it would have automatically picked my virtual environment. But since I had it running, I have to go here and find my demo 2 virtual environment to be able to run my code against. Where is it? Watch me not be able to find it. I can't find it. So I'll find it. Anaconda 3. I don't want Spotify test. I want demo 2. Bin. Python. All right. So now I'm in the right virtual environment for when I run my code. There's a plugin called Code Runner, which makes life very easy. So to find these extensions in Visual Studio Code, you see the blocks on the left here, extensions. I have Anaconda extension pack installed. And then there's Code Runner, which gives you a little play button for all your Python stuff, which is kind of cool. And I actually lied. I have the GitHub one installed, but you should have the Git plugin installed, not GitHub. Either will work. I have found with students that the Git one works better. All right, so you're now virtual environment experts. All right, that setup.py file we looked at quickly. But in my repository, at the top level, I have a setup.py file. In there, it's mostly always copy paste boilerplate and change the name of your application. Make up a version number. Version number really only matters if you actually publish your application to those repositories, which we won't do. So version number is almost irrelevant. Descriptions are good, author metadata, and then the packages command makes sure that it knows what applications you have in your Python code. So copy paste that as your setup.py file always, but just kind of change the name, version, description, and author information. And that name here should match that the folder name where you have your code. Doc strings we talked about, module level, function level, class level. We'll get in the habit of using these. The reason I'm going through all of this really is to build that habit of properly documenting and running your code. So I don't know if you noticed when we were looking through some of those things, there are two ways of following cases, or naming your variables and functions and stuff. Your function names and your variable names will follow snake case, which means it's a word or phrase, and if it's a phrase, anything with a space would be an underscore. So if it's multiple words separated by an underscore. So if, as an example, my function is my underscore function, all lowercase, not my capital M, lowercase y, capital F, lowercase function, or all lowercase. Like these are not snake case. This is snake case, and we will use that for our function names and our variable names. When we start talking about classes, they are all camel cased. So no underscores, words are capitalized. So single word, automobile, capital A, lowercase the rest. Double word, skyscraper, each word is capitalized. So that's snake case at the top and camel case at the bottom. I don't know why they're called those, but they are. I'm sure there's a reason for it. And we have homework for next week. This one should be easy because we did it tonight. Except I broke my repository. I'll fix my repository by the time you're done. So I want you to fork that repository, test repo into your account. Make some sort of change in your README file. Specifically, which is your favorite tool that we talked about tonight? Black, Pylint, or iSort? There's no wrong answer. I just want you to put something in your README file and then commit it and push it back to GitHub. Once you've done that, send me a link to your README file. So if I go to my repository, whoops. Let me do it a different way. Let's go back to my repository. If I wanted to send someone a link to my readme.md file, my computer is dragging today. I would find the readme.md file, click it, copy the URL from the browser, and that's what I'm going to submit on Canvas. Today we added a change for the live demo in class. When you clone it or when you fork it, you should put in another line at the end that says something about one of the tools we used today. You don't have to do a pull request. I'm not going to pull it back into my repository. I just want to make sure that you are interacting with GitHub properly. Any questions about anything or about the homework?
If you
I'm
fork,
curious.
go
Go
ahead.
ahead.
If you fork a repository and the repository changed, do you refork it?
There is a way to synchronize it. And let's figure that out real quick because that's going to be important for you because I'm about to change it. If you've already forked it, we're going to have to figure that one out. So let's do that real quick. Desktop projects. Somehow it's Anaconda's fault. Let's quit Anaconda. There we go. Make sure I'm using the one from my VCU repo. So I have done all those changes in my Chris Fauerbach account, and I did my merging and everything in the GitHub user interface. So since I already had the repository cloned, I have to get the latest version. So I'm going to run git space pull, or if I were in Visual Studio Code, I would go to my version control tab. What? Test repo. Refresh. There's a button somewhere here. Here we go. On the ellipsis, I would pull. So that pulls the changes down from GitHub. So the same thing as doing git pull here. So I'm up to date because I just did that. So let's figure out what was wrong with that file. So Pylint, make sure I'm in my virtual environment. Python m Pylint. Oops, name of the file. There's the tests one it didn't like, right? Final new line missing. Okay. Pylint didn't like that. So I'm going to add a new line here at the end. Pylint likes that.
Obnoxious. Oh,
Now I have trailing new lines. What the? On line 20. So what's line 20? Maybe I had too many. I must have added 2 and not 1. There we go. Okay. So now Pylint's good. So let's check isort. I guess isort's now happy. Black test 1. Okay, so it did reformat it like we did in the other repository. So now I'm going to add that file to my transaction. Now I'm going to commit my transaction with a message. I remember I typed a message in Visual Studio Code saying like, this is my check-in, fixing Pylint black for the test file. And now I'm going to push it back to my VCU edu repository, or my VCU repository. Okay, so there's that. And I'm going to go back to, I think this is my VCU account. Who am I'm logged in as my, I'm going to go back to my VCU account. I should have 2 different browsers logged in at the same time. That make life easier or faster. I want my VCU email. I'm going to make sure my code made it. Fixing Pylint black test. So you can see here that it's the comment that last changed that folder. So I know it's the right code. Test1.py. I guess I have 1 trailing new line character and not 2 at the end. I'm going to check my actions to see if they passed. Okay, so it built and my test cases ran. Pylint succeeded. And now it's going through Superlinter, which does a couple of other tools. That's where it runs isort and black. So that will pass. Okay, so now if I go back to where I have it forked, going back to the question, we'll see how I update it. I think it's just a button. It'll do what's called a sync in Git. I think it's sync. Oh no, I need the fork of it. Where's my fork? Oh, y'all are already forking it like crazy, huh? Let's go to my fork. Oh, don't fork that one. Don't fork the one from Chris Fauerbach. Fork the one from VCU. So yeah, okay, this is my Chris Fauerbach forked from VCU, Chris Fauerbach. There should be a way. No. There is a way to do this, and I can't remember. Oh, here we go. Now it's telling me this branch is 2 commits behind. So you see now I got this little pop up here. Compare. So I want to take from VCU to, oopsie. That's just to see the differences. So it went back to that one. This is my confusion doing it across two different accounts. Do a pull request. No, that's pushing it up. I'm gonna Google that. Okay, so from the command line, that's how I do it. I don't want to do it on the command line. I want to do it in the user interface.
I think I figured it out. You do a pull request and you line them up.
The other way from the master to yours?
I think you have to put the same one
Yep.
in both places.
So it is so it's a pull request. Okay. So pull request. So I want to change my local from, no, that's not what I want to do.
From what I'm reading, you do a pull request from the original repo to your fork.
It's messing me up. From original repo. It's not letting me do what I think it's supposed to be doing. So let's do it from the command line. Where'd that go? Here we go. Okay, so on the left is my Chris Fauerbach one. So git fetch upstream. Upstream does not appear to exist.
I think I figured out in the GUI, you have to click on something, compare across forks.
You'd think this would be easier. Is that the, I know what you're talking about. Go back to, where's my fork? I want my fork. Yeah. Compare across forks. But I want to go the other way. Oh, there we go. I don't know why all of a sudden it's laying out how I want it to lay out. But on the right is the head repository of the original. On the left was my fork. And I'm making a pull request kind of backwards. Now I merged it. So then my local repo should be right. Oops. All right, it still says it's one ahead, so let's try that again. Pull request. This is not going to work until I hit compare across forks. Now VCU head on the left is the target. I want to go from VCU to my target. Okay, there's no changes this time. But if there were, oh, my change is one ahead now. My Chris Fauerbach has one change. So I could make a pull request back. Anyway. So yeah, that compare across forks is what did it. Good find.
And so I'm curious about editability here. So I assume that you've configured your repo or this particular repo to allow us access. And so we can create our own fork and do a push request. I don't assume that you would be able to do a push request onto our repo until we set something up. Does that sound right to you? I'm curious. I mean, I'm not.
Yeah. So GitHub has different permissions on it. So I can have a public repository, which anyone can read, and fork. Anyone can create a pull request back to, but me as the maintainer, I don't have to accept the pull request. That's how open source software works.
And so by default, is everything public?
On GitHub, when you create the repository, you can select it. There's no, I wouldn't say there's maybe the default is public, but you can't create it until you pick one, either public or private. So it's not like you create the repository, then change it. But when you create it, you can make it in public or private. But if you're forking a public repository, by default, it will be public.
Good to know.
Alexis, yes, you're absolutely welcome to watch the Zoom and try to find where I said things correctly while you're doing your homework. Absolutely.
The first Zoom video isn't available on YouTube.
Say again?
Like the first YouTube video that you posted a while back, it's unavailable.
My video?
The one on the announcements.
Oh, it is. Oh, okay. I may have to find a new video. I'll look for that after class.
Yeah, I don't see it on the YouTube channel.
Uh-oh. Which one? The GitHub one?
Just the first video from that you said you posted from the first class.
Oh, so my video.
Yeah.
Okay, that's odd. I'll double check them. Sorry about that.
Is the PDF link for week 2 on your GitHub is saying 404 file not found. I'm not sure if you've posted that yet, but
Yeah, I thought it did. I thought it did. Oops.
Is this on your regular GitHub or the VCU one?
The regular one.
Okay.
Could not read from remote. I got to figure out my permissions. I think I've confused myself and my computer having 2 repositories or 2 accounts. Oh. Yeah, I think my SSH keys are confusing it. I'll fix it. Next week, we will have class, but I will be on vacation and we'll be skiing that day. So I hope I don't break a leg and we have class. Just F.
hope you have fun. Hope to see you in class.
Oh, you will. I'll be here. We'll actually look at Python next week and we'll learn Python. I don't think I couldn't go another week without doing it. So next week we'll do it. So the overall process here about version control for your code, how the files are going to be organized, how we'll be using GitHub. Is that starting to ring a bell? Is that starting to sound reasonable?
Yeah.
So what I'm going to do for real homework going on in the future, I am going to be creating a repository under my VCU account for each of you. So I will have 50 repositories with some identifier so you know it's yours. You will fork it to your account, make your changes there. You will commit and push back, and you'll make a pull request to my repository, which I will accept. And when I accept it, your grade will be determined based on how all those automated testings run. The good thing for you, though, when you commit and push to your own repository, those actions will run there too. So you won't do a pull request until they work. Or say that better. If they work for you, they'll work for me, so you should feel confident in a decent grade. That's the way to say it. If there are no more questions, I will stop the recording.
Just one question. Just I forgot. Sorry, you probably already said it, but the thing we're forking for the assignment is under your VCU GitHub, right?
Correct. I just put it in the chat link a minute ago, wherever the heck
Ah.
my chat link went.
I
I
don't
think.
see it. Maybe I don't know.
Didn't I? Thought I did. Chat. Oh, no, I didn't. I meant to.
It's the
There
thought
you
that
go.
counts. Thank you.
Exactly. That's the one I want you to fork. So when you send me your README file link, I will look at it. I will make sure it says something on it that I didn't put in it. And as long as it does, easy 100 grade for that one. I try to make the first couple easy because they get hard quick. But we go by step on everything, so it won't
Wait,
be that
so
hard. It won't be that bad.
just because it sounds easy and I know I'll mess it up, I'm gonna ask and just clarify. So all we
Please
have to,
do.
all we have to do is make an edit to it and essentially like install one of the like program or one of the packages that you showed us today, and that's it. And then like
No, not even that.
perfect. Oh,
You just have to clone the fork the repository.
Yeah.
Clone it to your desktop. Change that README file. Commit it and push it back to GitHub on your account. That's all you're doing.
A change could just be like literally like changing a word.
Yeah. I liked the black package. I liked the iSort package. I liked the whatever. I don't care what you write in there, really.
Gotcha.
Just something.
oh wow. Okay.
Yeah. Like that easy.
Sounds good. All right. Yeah, I don't have any questions.
Thank you.
You're welcome. All right. On that, I'll stop my recording. And I will stick around until the last one of y'all leaves. And we can talk about anything.
Take it
Or
easy.
nothing. You too.